All right, so this is the last thing we're gonna do for this section. So last time, we got this formula here for the slope of the tangent line to a polar curve. So here r is equal to, some function of theta, like we've been doing for the graphing stuff. And so let's just do an example. So for r equals 1 plus sine theta, find the slope of the tangent line when theta is equal to pi over 3. So that graph there, r is equal to 1 sine theta, was the cardioid that we saw in an earlier example. So what we're going to do is we're just going to, we're going to use this formula here. So dy dx, sorry, is equal to dr d theta sine theta plus r cosine theta divided by dr d theta cosine theta minus r sine theta. Here r is equal to 1 plus sine theta, so we have dr d theta is equal to cosine theta. I take that derivative. Now I'm just going to plug everything in. So this is going to be equal to, so dr d theta is cosine theta sine theta plus r, I have to replace in terms of theta, so this is going to be 1 plus sine theta times cosine theta divided by dr d theta again is cosine theta. I'm going to multiply that by cosine theta minus r, I'm going to replace with 1 plus sine theta, just so everything's in terms of theta, and then cosine theta. Let's do some simplifications. Hang on, so that should be a sine theta instead of a cosine theta. So let's do some simplifications. So this is going to be the top. When you do expand that out, you're going to get 2 cosine theta sine theta plus cosine theta divided by cosine squared theta minus sine squared theta minus sine theta. Let's just try and clean this up a little bit. So the top, I'm going to get 2 cosine, let's factor out the cosine theta. I'm going to get 2 sine theta plus 1. The bottom, I'm going to rewrite cosine squared as 1 minus sine squared theta minus sine squared theta minus sine theta. So that first 1 minus sine squared comes from the fact that cosine squared is 1 minus sine squared. Top, I'm going to leave alone from here on out. I'm just simplifying everything to make it easier to work with. Then down bottom, I'm going to have 1 minus 2 sine squared theta minus sine theta. And then the bottom will actually factor now. So the bottom is going to be 2 sine theta, so negative 2, minus 2 sine theta times something with a sine theta. And so when I do this, I'm going to get 1 and 1, it looks like, when I do that factorization. So this just makes everything easier to, work out. Okay, so part A, again, just to refresh your memory, was to find the slope of the tangent line when theta is equal to pi over 3. So this thing here is, dy dx. What I want to do is I want to find dy dx at theta is equal to pi over 3. You don't have to do all that simplification I did. It's just going to make it way easier to plug into here. You can leave it like it was to begin with, and it works just fine. 2 sine of pi over 3 plus 1, just plugging pi over 3 in for theta here. Part of the reason why, I do all the simplifications because the book does it. And if you're looking through the book, you might get lost at some steps. I like to make sure, it's all clear about what's going on. So cosine of pi over 3 is a half. Sine of pi over 3 is square root of 3 over 2. Down bottom, I'm going to have negative 2 square root of 3 over 2 plus 1. And then 3 over 2 plus 1. So the top then is going to be, so 1/2 square root of 3 plus 1. On bottom, that was, okay, so I'm going to have to end up foiling that out anyway. So that is really annoying. Okay, so let's just do that. So we're going to get what here? So radical 3 times, so we're going to get negative 3 over 2 for the first term, minus radical 3. So I'm just expanding the bottom, doing some of the math in my head. As I go. So that'll be what you get when you do when you expand the bottom. So this is 1/2 square root of 3 plus 1 divided by, so I'm going to get, so when I do this, 1 minus radical 3 over 2 is minus 1/2. Negative radical 3 plus radical 3 over 2, that is going to be radical 3 over 2. So if I factor out a minus 1/2 from the bottom, and again, this might have been the more convoluted way to do this, it's fine though. So if I factor out a minus 1/2, I'm going to get 1 plus square root of 3. These are the same top and bottom here. They cancel, so I get 1/2 over negative 1/2. This is negative 1. And that's my answer for the first one. Part B is to determine where the tangent line is horizontal. Where it's horizontal or vertical. So what we're going to do for that is we're going to take the original derivative. I guess we're going to do it from there. So cosine theta, 2 sine theta plus 1. I'm sure there's a grab tool that I'm not using. Negative 2 sine theta plus 1 times sine theta plus 1. So this was the reason why we factored all of this. That way we can easily figure out where these things are 0. So the top, if I have cosine theta cosine theta times 2 sine theta plus 1 is equal to 0. If this thing is equal to 0, so if I set the numerator equal to 0, I get cosine theta is equal to 0, or 2 sine theta plus 1 is equal to 0. So cosine of theta is equal to 0. This is that theta is equal to pi over 2, 3 pi over 2, so on and so forth. And then, well, I guess, okay, we'll stay between 0 and 2 pi. So this is 0 pi over 2 and 3 pi over 2. This second equation is the same thing as sine theta is equal to minus 1/2. This happens at theta is equal to, so you can, draw out the unit circle, all that jazz. So you're going to get 7 pi over 6, so that's, you want to be in the third and fourth quadrant here. So 7 pi over 6, 11 pi over 6. So this is everywhere where the numerator is 0. And now I need to figure out all the spots where the denominator is 0, and then, we'll figure out from there where we have horizontal and vertical tangents. So this was for the numerator. And now we'll do the denominator. So the denominator is sine theta plus 1 times 1 minus 2 sine theta. So this gives me, again, sine theta is equal to -1, or sine theta is equal to 1/2. So I'm just solving these two equations for theta here. So the first equation is going to happen at theta is equal to 3 pi over 2. And this second equation happens when theta is equal to 5 pi over 6 or 5 pi over 6. Okie dokie. So what we want to notice now is we want to figure out what values these have in common. So these share a value of 3 pi over 2, and that is it. So from this, I can immediately tell we have horizontal tangents at the values boxed in blue without red. So we have horizontal tangents at, let's see, so we have pi over 2, 7 pi over 6, and 11 pi over 6. We have vertical tangents for sure at pi over 6 and 5 pi over 6, because the denominator is 0 and the numerator is not 0. We now have to treat this value boxed in red using limits. So we need to check theta is equal to 3 pi over 2. Okay, so let's just go ahead and do this then. So we're going to have the limit as theta approaches 3 pi over 2 from the left of dy dx. This is going to be equal to the limit as okay, so what we're going to do here is, okay, so yeah, so I'll walk through this slowly. So cosine theta, so limit theta approaches 3 pi over 2 from the left. Cosine theta, 2 sine theta plus 1 divided by negative 2 sine theta plus 1 times sine theta plus 1. Now what we're going to do is we're going to, use the fact that, so if I look at, which of the functions are going to 0 there, it's going to be the cosine theta, it's going to be the cosine theta and the sine theta plus 1. So I can split this into two limits then to try and do this. So this is going to be the limit theta approaches 3 pi over 2 from the left of 2 sine theta plus 1 divided by negative 2, make sure I'm doing this, have the right one, yeah. Negative 2 sine theta plus 1 times the limit theta approaches 3 pi over 2 from the left of cosine theta over sine theta plus 1. So what I've done is I've split this into the product of limits where this is not going to 0 over 0, it's going to a number, but this is going to 0 over 0. So now I'm going to evaluate both of these limits. So if I plug in 3 pi over 2 here, so this first one I'm going to get, so sine of 3 pi over 2 is negative 1. So I'm going to get negative 2 plus 1 divided by 2 plus 1 here. I'm going to multiply that by, so I'm doing the limit theta approaches 3 pi over 2 from the left. This is, this is going to be 0 over 0 indeterminate. Because cosine's going to 0 and sine's going to negative 1. So if I do L'Hopital's and take the derivative, I have minus sine theta over cosine theta. It's going to be 1 over 3 times, so the limit as theta goes to 3 pi over 2 from the left. So as we do that, sine theta will be going to -1, and then cosine theta will be going to 0 still. So this is going to be diverging to infinity. So -3 times, so let me write it one more time. Limit theta goes to 3 pi over 2 from the left, minus sine theta over cosine theta. This is going off to infinity, so this limit is infinite. And you can do the same thing for theta approaching 3 pi over 2 from the right of dy dx. You can also, if you go back and look at the graph, it is the cardioid, so if you remember that. So what this looks like is this. It's going to look something like this. So from the left, it's going off to infinity. From the right, it's going to be going off to minus infinity by symmetry. Or you can actually do the limit if you want. You'll get the same answer. So that's where I'm going to stop. So that is the end of this section. There is another thing on graphing these polar curves with graphing devices. We don't use graphing devices, so it doesn't matter. You need to know how to do it without them first anyway. So I'm going to stop here. If you have questions or if you see something that doesn't make sense, comment on the YouTube video. Even if this is like 3 weeks from now and you're taking your next exam, I'll still answer comments on the YouTube videos. But yeah, so that'll be it. So I'll stop here.